So now let's take a look at a couple examples of evaluating the indeterminate difference. First up, we have the limit as x approaches 1 of x over x minus 1 minus 1 over the natural log of x. If we attempt to use the direct substitution property, first fraction will be 1 over 1 minus 1, and the second fraction will be 1 over natural log of 1. This, of course, would be the form infinity minus infinity. Now, as I said on the previous example, what we're looking to do is establish a lowest common denominator. The two denominators that I see are x minus 1 and the natural log of x, so the product of those is going to be our lowest common denominator. So for the first fraction, I'm going to multiply top and bottom by the natural log of x to establish that lowest common denominator. And on the second fraction, I'm going to multiply top and bottom by x minus 1. Careful to use an extra set of parentheses when we have multiple terms. So for both of the fractions, we now have the appropriate denominator, so we can go ahead and combine them into one single fraction. That denominator is going to be x minus 1 times the natural log of x. The numerator is going to be x times the natural log of x minus the quantity x minus 1. So I predict we'll see some distributive property happen on that and turn that into a plus 1. Now at this point, if you wanted to try the direct substitution property one more time, just to see what we have, now that we're in terms of one single fraction, 1 times the natural log of 1 is 0, and 1 minus 1 is 0. Your numerator is 0. 1 minus 1 is 0, and the natural log of 1 is 0. Your denominator is 0 times 0. Now that you have the indeterminate fraction, or indeterminate quotient, we can apply L'Hopital's rule. L'Hopital's rule says, let's differentiate the numerator. For x times the natural log of x, we're going to use the product rule for this. So first times derivative of the second minus second times derivative of the first. And for this term here, we're simply going to differentiate the x and we'll leave the minus sign in front. So that'll be minus 1. Denominator will be doing something similar, product rule for this. So first times derivative of the second plus the second times the derivative of the first being x minus 1, so that'll be 1. Oh my gosh, we need to do so much algebra here. Let's see. Oh, also I've screwed something up. First times derivative of the second plus second times derivative of the first. Thank you for everybody who caught that. So let's do some algebra, see if we can simplify this a bit. So x times 1 over x, that'll be 1. Natural log of x times 1 will be natural log of x. We'll see a minus 1 at the end. In the denominator, oh boy, this looks like it's going to be fun. We have x minus 1 divided by x plus the natural log of x. I think I'm going to do some additional algebra in that denominator. Your options at this point are you could multiply top and bottom by an x to clear out the fraction inside the fraction. I think what I'm going to do instead is just distribute that x in the denominator to both of the terms in its numerator. So numerator, we'll see a 1 minus 1. Those will cancel to leave 0. So natural log of x is what's left. X over x will be 1 minus 1 over x. 1 over x we're going to express as x to the negative 1 power in anticipation of what we're about to do next. The thing that we're about to do next is, notice that if we attempt to plug in x equals 1 one more time, numerator is the natural log of 1, which is 0. Denominator is 1 minus the reciprocal of 1, which would be 1. 1 minus 1 is 0, plus the natural log of 1, which is 0. So with those things in mind, 0 divided by 0, let's apply L'Hopital's rule one more time. Applying L'Hopital's rule once more, this will be the limit as x goes to 1 of. Numerator is now derivative of the natural log of x, which is 1 over x. Denominator, derivative of 1 is 0. Negative x to the negative 1, we can apply the power rule and call that positive x to the negative 2. plus the derivative of the natural log of x, which is 1 over x. At this point, I'm not going to try to simplify anything. I'm going to go directly to the direct substitution property and just plug in x equals 1. Your numerator is 1 over 1, that is 1. Denominator is 1 to the negative 2 power, 1 to any power should be 1, and 1 over 1 would be 1. Final answer for this one, that'll be 1/2. So, a little bit longer process than the ones that we've seen so far, but that's okay. Let's try out one more example. The other example that I have for you is limit as x approaches 0 from the right-hand side of 1 over x minus 1 over the arctangent of x. So first things first, we'll start with the direct substitution property. We'll get 1 over 0 minus 1 over 0. Both of those zeros happen to be in the positive direction, so this will be positive infinity minus positive infinity. There's our indeterminate difference. So like we did on the previous problem, we are going to establish a lowest common denominator. That lowest common denominator is going to be, I see a denominator of x, and I see a denominator of arctangent of x. Multiplying those together will give us our lowest common denominator. So for the first fraction, I will be multiplying top and bottom by the arctangent of x. And for the second fraction, which already has an arctangent, we're going to be multiplying top and bottom of that one simply by x. This changes both of the fractions so that they have the same common denominator. Because they now have the same common denominator, I'm going to express it in terms of that. Now the first numerator that we would get is arctangent of x times 1. We'll just call that arctangent of x. And the second denominator is 1 times x. We'll just call that x. Once we are to this form, we can attempt to use the direct substitution property just to make sure that we know what we're looking at. As x approaches 0, this will be 0 minus 0 up top, and your denominator is now 0 times 0. Because we have the indeterminate quotient, this allows us to use L'Hopital's rule. So we will differentiate the top, and we'll differentiate the bottom. Differentiating the top, derivative of arctangent is 1 over 1 plus x squared minus, plug in x, or take the derivative of x, we'll get 1. In the denominator, we will do product rule. So first times derivative of the second plus second times derivative of the first. This is going to give us some very gnarly fractions inside of a fraction. I would also like to point out that if we attempted to use the direct substitution property once more, your numerator is going to wind up being 1 over 1 minus 1. That is still 0. Your denominator is 0 times 1 plus 0. That will still be 0. So your options are we can go directly to L'Hopital's rule, or we can perform some algebraic manipulations. I'm going to insist that you perform some algebraic manipulations. Specifically, I want to multiply top and bottom of the big fraction by 1 plus x squared. That'll clear out the fractions inside the fraction that we have, but it is going to distribute through to both terms. So in the numerator, we distribute the 1 plus x squared to both terms. This will become 1 minus 1 times 1 plus x squared. In your denominator, this will once again distribute to both terms. So distributing to the first term, that'll simply cancel out the fraction that's already there. And on the second term, it sticks around. Continuing to, algebraically simplify the numerator, this will be the limit as x approaches 0 from the right of, distribute the minus sign and get rid of the ones, or cancel the ones, I suppose. And we'll get x plus, not a whole lot to do here, so we'll just leave it in its current form. If you were to attempt to use the direct substitution property at this point, That is still going to yield 0 on top and 0 plus 0 in the denominator, so we'll call that 0 over 0. We can apply L'Hopital's rule once again. L'Hopital's rule says take the derivative of the top. Derivative of negative x squared would be negative 2x. Derivative of the denominator, oh boy, buckle up for this one. Derivative of x, that'll be 1, no problem there. But for these guys, we'll need to use the product rule. So first times derivative of the second, that's convenient, plus the second times the derivative of the first. Wow. So with that in mind, I am going to attempt to use the direct substitution property one last time because I believe good things are about to happen. Plug in 0 to the numerator. Numerator becomes negative 2 times 0. Your denominator, we will see 1 plus. When I plug in x equals 0, this term becomes 1, this term becomes 1. 1 times 1 over 1 will be 1. And over here we'll have 0 times 2 times 0. That was a lot of work to get an answer of 0. So whose infinity was bigger in this example? Turns out they were the same infinity. Cool.